Welcome back to my YouTube channel. In this video, I am going to discuss about dimension of a physical quantity. We all know that any derived quantity can be expressed in terms of basic quantity or fundamental quantity. Okay, so in a derived quantity, there are so many powers of fundamental quantities will be there. That means if you take an example of an acceleration, that will get us velocity divided by time. Okay, that is again will get us displacement, velocity is equal to displacement divided by time. So from this, the power of displacement is 1 and the power of time is -2. Okay, so if we want to know how many powers of fundamental quantity was there in a derived quantity, we will use dimension methodology. It will easily help you to find that. Okay, what is dimension means? Dimension represent how many powers of fundamental quantity present in a physical quantity. Okay, so we can write present in the physical quantity. That is, dimension of a physical quantity represent how many powers of fundamental quantity present in a physical quantity. Okay, then if we need to convert one system of unit to another system of unit, we can use dimension. And if we want to check an equation is correct or not, we can use the dimension analysis. And another thing is that if we want to derive a formula, we can use dimension analysis. Okay, so the dimension analysis is important. Okay, so how we will write the dimension of a physical quantity, we will see now. The dimension of a physical quantity is denoted in square bracket. Denoted in a square bracket. Okay. How we can draw the dimension means there is a separate symbol is assigned for 7 fundamental quantities. These are all the symbols. For length, the dimension symbol is L, and for mass, the dimension symbol is M, and for time, dimension symbol is capital T, and temperature, dimension symbol is K, and for electric current, dimension symbol is A, and 6 for luminous intensity, dimension symbol is CD, and for amount of substance, the dimension symbol is MY. This is the 7 symbols are assigned for each fundamental quantity. You can easily remember this. You look at first 3 quantities. You look length, mass, time. The first letter in capital. Next 4 quantity. You look at these symbols. They are the units itself. Okay. So you can easily remember. If you know this order, you can easily remember this. First 3 quantities, the first letter is in capital. Next 4 quantities, the unit itself. This way you can remember this. Clear? And now we will see how we can write dimension of a physical quantity. Okay? Then first we will see velocity. Velocity, what is formula? Displacement by time. So what we studied, by using these 7 symbols, we can write the dimension. We will check displacement. Is there any displacement? Is there no displacement? Only length, mass, time, like this. So this, now you see that displacement means actually what? You see that displacement is, it is length actually. Shortest distance between 2 points. So always length means it is to be confusing. So they are given a separate name for that shortest distance. That is displacement. Okay. So actually that base quantity is what? Length. So we can give a symbol L and the symbol for the time t. So we can write velocity dimension like this. We can denote, and we will get L t power minus 1. Like this we can write. Okay. And easily you can understand. Check the unit of displacement. What is that? Meter. You check it. Which of these quantity have same unit? Then you can use the same symbol. Okay. So here length has the same unit. So we are using the same symbol. Okay. Clear? This is the way we can write. So we will write this B is equal to L t power minus 1. This equation is called as dimensional equation or dimensional formula. Clear? By using this, we can find the dimension of any derived quantity. Okay. Now I will write one more example. That is, I will take an example of G. That is the universal gravitational constant G. I will write. Okay. So what is the dimension of G? Anybody have any idea about this G? G is what? It is a universal gravitational constant. So I need a formula. Then only I can find a dimension of G. So I know G was to be there in universal gravitational equation. So what is universal gravitational law? If two masses are separated by a small distance, the force F is equal to G m1 m2 divided by r. R is a distance. From this I will get G is equal to what? You will get F r square divided by m1 m2. Okay. So if I need to find out the dimension of G, you take the dimension of force and dimension of r square, dimension of m1 and dimension of m2. Okay. What is the force dimension? Force is equal to mass into acceleration. Mass into acceleration means m L t power minus 2. L t power minus 2 is the dimension of acceleration. This velocity divided by time. And the dimension of this r is distance. Distance is similar to length. So we will write L square divided by m is the dimension of first and m is the dimension of time. This m and m is cancelled. 1 m goes there. So what do you get? M power minus 1. Here L power is 1. Here L power is 2. So we will get as L power 3 and t power minus 2. This is the dimension of a universal gravitational constant. Clear? Okay. Next we will see, based on the dimension, we have classified the constant and variable into 4 categories. What are that categories? We will see now. Okay? Types of constant and variable. Based on dimension. Okay? Based on dimension, the constant and variable are classified into 4 types. First one is dimensional variable. That means the variable have dimension. Okay? That means, what is variable? Variable means the physical quantity, its value is not to be constant. So you can take an example of velocity. Velocity have dimension, already we got. Next we take it as force. So likewise, how many things are there? That is dimension and variable. Next, dimensionless variable. The variable does not have a dimension. Okay, it is a variable but does not have a dimension. Like that, variables are there. Example is strain. Mechanical strain. You will study in the chapter of mechanical properties of solid. What is strain? Any idea? Strain. Strain means change in length by original length. Change in length by original length. If we will take the dimension of strain, dimension of change in length. Change in length, how? Same dimension of length divided by L. So what? It has no dimension. This length and length cancel. Next, specific gravity. That means relative density. So this is also what you get. No dimension. Next, refractive index of a medium. Refractive index. What is the refractive index? Refractive index is equal to C. That means velocity of light in vacuum divided by velocity of light in medium. 2 numerator and denominator velocity. This we can cancel, so we will get no dimension for this quantity. Clear? Okay. Next, third one is dimensional constant. That means the constant have dimension. Some constant have dimension. We already find out a constant have a dimension. That is what? That is universal gravitational constant. Constant. And another constant, we can take it as G. What is G? Acceleration due to gravity, its value is 9.8. What is dimension? It is an acceleration. Its dimension is, it is an acceleration. So its dimension is LT power minus 2. Okay. So this is the other classification. And we will go to the last classification, that is dimensionless constant. That means the constant does not have the dimension. That is, examples are pi, numbers, and all the trigonometric values. And the exponential value, all these does not have dimension values. Okay, this is the basics of the dimension.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like